Do you really know how much it costs to use an AI tool? In this episode of AI Insights with John Roese, I want to talk about token economics and the economic side of AI in a lot more detail. You know, as AI tools proliferate across the organization, as we start to deploy more AI capabilities, most of us are very excited about what they can do. We see the outcomes. In many cases, they have significant impact on our business processes, our performance, even the revenue and profit of the companies. But the reality is most people using these tools are not really aware that they come with a cost. There are no free AI tools in the world. Somewhere in the stack, there is an economic cost of using that tool. And the reality is, while every tool has a cost, we've never had tools that actually could have this much cost if they're used or misused by the people in our organizations. And so the reality is, as we go into the AI cycle, this ability for all of us, not just the IT people or the finance people, but all of us, to really be aware that your choice of not just which AI tool you use, but how you use it directly correlates to how much cost that particular activity has on your company and organization. Because if you get the costs wrong, and if you use them in the wrong way, and suddenly to produce $1 of value, the tools cost $100 to do that task, you have a go out of business strategy for your company that you didn't even know you were choosing to make. One observation I make to people is, what makes this different is our relationship with IT tools historically did not include understanding the finances below them. At best, we understood that there was a monthly license or some arbitrary cost, and we never really understood the cost behind the scenes. I ask people sometimes, do you know how much it costs to send one email? No, of course you don't. We don't think about that. But it is important when you start using an advanced AI tool to know how much it costs or how economically impactful it is to build one library of code or to transact one customer service engagement. Because if you don't understand that and you implement it in the wrong way and it becomes cost prohibitive versus the value it creates, you end up with a business model that falls apart. So as we go into the AI era, I am spending a great deal of time trying to educate the population of Dell and the population of our customers about how to think about the economics of AI in a way that the end user can be a participant. Because ultimately, the thing that will differentiate good in AI economics is not the technical architecture that gets put in place. It's that plus the education and awareness of the user community so that they can take these incredibly flexible and powerful tools and use them in the right way that achieves the right outcome, but does that in the most efficient way possible. A well-informed customer base of an AI environment is an incredibly powerful tool to mitigate unplanned, unexpected, or out-of-control costs. So I want to talk about a few examples of what to think about in this particular topic. The first is when we think about developing an AI solution, we have two problems. The first problem is we don't even know what the solution is. We've never done this before, so it will require experimentation. The second problem is, okay, once we figure out how to do it, can we do it in an efficient way that becomes cost effective? And the reality of it is when we think about that dynamic tension in the AI cycle, you have to make a decision. And the decision is, do you want to move fast and then optimize, or do you want to move and optimize at the same time? Now, you would think my answer would be to do the second, and I will tell you, we've chosen to do the exact opposite. We have realized that because we are learning how to apply coding assistance, how to use AI in all dimensions of our company, that we actually allow for some sloppiness is a good way to describe it. We don't require you to optimize every model and optimize the entire stack while you're experimenting and figuring out how to best use coding assistance in spec-driven development or how to transform your service organization or do agentic planning. But we always follow up after we've figured out how to make it work using the best tools available with an optimization phase that says, now that we know how it works, can we tune it to move to cheaper models, to move to more efficient systems, to use data more effectively, and ultimately drive the cost down? This decision about what is the balance between optimization and innovation is critical when we think about how we'll navigate AI. If you require optimization at the same time that you're innovating, your innovation cycles will go much slower. If you don't require optimization at all, your innovation will eventually cost you out of business. But having a balance between the two in the right order, we think is the right answer. The second is that behind the scenes, model diversity is now a very real thing. We at Dell have 5 different ways that we can serve models of different flavors, different costs, different performance, different controls to our use cases in the company. We have large internal AI environments running on GPUs that we control that run open models. We have frontier models running in our environment in partnership with some of the frontier model companies, private, fixed cost, well understood, completely under our control. We have access to private models running in kind of as a service flexible environments. We have API interfaces, and now we have personal agents where we can deploy things directly out onto the device. All of those choices, those options, are not there arbitrarily. They're there because every one of them has a different cost benefit associated with it. Some of them give you slightly less functionality at the advantage of incredibly predictable costs and incredibly low cost. Other ones give you the most advanced capability in the world, but they also bring with them the most expensive costs in the world. And so the reality is there isn't a right or wrong answer, but there is one wrong answer, and that is that you have no choice. You only get one option. We chose to create multiple options. That's what we call hybrid AI, which means that there are some served AIs to us, some virtual served to us, some physically owned by us, other ones that are local, other ones that are centralized, other ones that are distributed. And the idea of having that spectrum of choice allows me to apply the right model and the right economics to the right use case. And I will tell you, that is the single most powerful leverage you have to keep the cost of AI under control. Now, the caveat is some use cases like agentic coding actually use multiple models. And you have to be smart about the fact that your spec development might need a frontier model, so you need that access. But the development of a crypto library might be better served with a private model running in your data center completely under your control. It will be more secure, but it will also be dramatically lower cost, and it will be equally as good as any other model because it's optimized. Bottom line is models matter. Choice in models are a foundational capability you'll need, and the ability to route the use cases or transactions to the most effective model will become a core skill in every enterprise to manage economics, not just performance, security, and control. The third is that the application is not the model. The model is a thing that serves intelligence to the application. Your application design matters. And the reason I share this with you is that there are very bad examples of people overusing reasoning agents to do things that they shouldn't be doing anymore. The fact is, reasoning agents are very good and reasoning models are very important if you have a complex task that requires kind of hierarchical planning and the ability to reason through that work. There is a ton of work that we currently ask AIs to do that does not need any of that could be equally done by a software application that just does that task. I'll give you an example. If you want to create a configuration for your customer, you sell a product and it can be configured in a trillion ways, there are 2 ways to solve that in the AI era. One is to load all your configuration data into the context window of an AI model and ask it to give you a configuration. That is bad for 2 reasons. One is these are probabilistic systems, so every time you ask it, it's going to give you a slightly different answer. But more importantly, the amount of tokens necessary to process all of that would be enormous. The cost to do that transaction would be almost prohibitive. The alternative approach is to have an agent that runs the configuration process, but when it gets to the point where it needs a configuration, why doesn't it just make an MCP call to a piece of software called a configurator that runs on a CPU that just gives it a predictable answer? We all have configurators. We built them for humans. And the reality is agents can use tools. So why not use the tools you have or enhance those tools to be agentic friendly? The difference in terms of token consumption between those 2 scenarios to get a configuration is gigantic. Maybe 3 orders of magnitude less tokens to do it with a configuration tool that is used by a reasoning agent as opposed to asking the reasoning agent to be the actual tool. Now, we're tempted to just let the AIs do everything. That is a very inefficient approach. The reason this matters is that it forces you to take a step back. And when you look at an entire application or use case, you should always be asking, what is the minimum sufficient use of a reasoning model or advanced AI in accomplishing that outcome? And then how do I surround it with tools and systems and logic and processes that make the entire system as efficient as possible? The third is that we have to think about our models as a moment in time. The reality is the frontier models today are infinitely better than the frontier models of a year ago. But a year ago, those frontier models were infinitely better than anything we had ever seen. And we were excited about them and we built really advanced capabilities. And so what's interesting is when you start thinking about a use case, it is critically important to recognize that you do not need best-in-class capability and state-of-the-art for every task in every scenario in an enterprise. In fact, once you get something working, you have an agent that gives you configurations using a model that exists today. 2 years from now, guess what? That task will work equally well. It will not get worse because a better model materialized. And adding a better model probably won't change the outcome if you architected it properly. And so the moral of the story is you don't want to be too tightly coupled to being always at state of the art and only having one model to use by having model agnostic tools that, quite frankly, are independent of the model. You can use the same model for a long period of time. You can change out the model if it makes sense. You get a tremendous amount of flexibility, but you also get cost control. Think about this. The cost of a N-3 model today is probably orders of magnitude less per token than the cost of the frontier model that you're using. And if you have a flexible architecture that allows you to use that N-3 model, if it makes sense, you've suddenly changed the overall economics of that outcome in a meaningful way. The bottom line is that there isn't a one-size-fits-all, but my point behind this discussion is to just make you aware that I never thought as a technologist that I'd be spending as much time on economics as I am today in the AI world, and I don't envision that changing. You as a technologist, you as a business leader, you as a person implementing AI probably are doing well in learning the technology and getting use cases into production, but the difference between success and failure in the AI cycle is ROI, which is how much return on a particular investment you get to impact your organization. Now, the return is about the value you create, but the investment is what we're talking about here. If you don't pay an equal amount of attention to the investment and the cost of your AI, and if you don't use the flexibility of the system, the hybrid architectures, the model selection, the application architecture as vehicles to optimize and simplify your architecture to reduce the cost to the minimum, you are actually leaving ROI on the table. Two equally good companies solving exactly the same problem, achieving the exact same upside, but one of them paid attention to how they were implementing it and was able to do it at 2 orders of magnitude lower cost in terms of token production and absolute cost. Which one wins? The second one every time. So this is an interesting time. We thought it would be all about technology. It isn't. Technology is important, but now we're dealing with sociology, psychology, and most importantly lately, tokenomics, which is really optimizing the economics of our AI systems so that we actually produce, one, sustainable AI projects that actually make sense, but more importantly, ones that actually achieve positive ROI and don't surprise us with the $100 million bill that we didn't anticipate.